another week, another video tutorial. So, since last week that this forum was created, there was one person who actually joined, and that is Mr. Munch. And Mr. Munch would like a mouse look tutorial, and since he's the only one to actually join and vote, he's going to get exactly what he wants. So I'm going to vote for his recommendation, and now he's number 1, and so he gets the tutorial that he asked for. And if you want to actually recommend a tutorial for next week, there will be another thread, and join up and vote. Okay, let's switch to our game logic view. Let me position this keyboard monitor here so you can see what I'm doing. And here's what we need to do first. Let me move this slide away. First, we need to parent this camera to this cube, because we're going to use this cube as our body, and our camera will be our head. And both of these need to rotate independently, but still they need to be related, obviously. So I'm going to clear location and clear rotation on the camera, and then make sure that it's looking out on the y-axis, and place it about there. And then I'm going to parent that with the cube. Okay, so now the camera is parented, and that's great. Let's also create a ground. So this is nice because we want to be able to see that we're actually doing the right thing as far as rotation goes, and having a line of sight that we can identify helps. And also an additional cube, maybe, in the distance, about there. Well, maybe a bit closer. Around there. And this plane should be down a bit. Okay, that looks fine to me. So first thing is, on the camera we need to have a mouse sensor. We need the mouse sensor, the mouse movement sensor to be precise. So select mouse movement. I'm going to call it mouse, all lowercase letters because that's the way I like to handle it, but you can call it whatever you want as long as you use the right sensor name in the code. I'm going to use mouse. And then a Python controller, which will be set to module execute mode. And then I'm going to create a movement actuator, motion actuator, call it ROTX, and on the body, so not on the camera, but on the cube that represents the body, I'm going to create another motion actuator, and then I'm going to select the camera in addition to the body so that I can attach the motion actuator on the cube to the controller on the camera. That way I can access both actuators from a single script here. Okay, and the ROTX motion actuator will be responsible for rotating the camera up and down, and ROTZ, or the actuator that I just named ROTZ, will be for rotating the body on the z-axis. Okay, that's the principle. So I'm going to create a new script. I'm going to call it mouselook.py, and in it there's going to be a function called main. It's not going to do anything now, but I'm going to set the controller to run that function, and then I'm going to go and create a mouselook class. So, obviously I'm assuming that you're familiar with Python classes at the very least, and I think it's a very convenient thing to use in this case, so that's why I'm using it. So here's the initialization function, or this would be the constructor, if you're coming from some other languages. So by default you have to pass this self in, and then the stuff that you want to pass. So I want to pass the controller. And the reason I want to do that is because I need to be able to get both this sensor and these actuators from this mouse look object that I will create using this mouselook class. So I have the controller, and I can use the controller to get the sensors, or the sensor in this case, because there's only one. So self send mouse, that's going to be my property name for the sensor here, and I'm going to get it by calling the controller. There's this dictionary-like object, which, if I give it a name of the sensor, returns the sensor object. And for the actuators, it's basically the same thing. So self.act, and then I want to get the rod X. So there's rod X, and I also want to get the rod Z. So okay, there you go. But also we'll need to activate these actuators. And you don't have to activate them on any frame or in every frame, you just need to activate them once, and then they remain active until deactivated. So we can just do that here. So controllers have the function to actually activate any given actuator, which means we call self.const.activate on self.act rod X. And same thing for rod Z. Okay, and now we also need the screen center, because the way our algorithm will work is we use the mouse offset from the center of the screen to determine our rotation values for these actuators. Right? So if we're moving the mouse away from the center in this direction, we know that we need to rotate both the camera and the body by some angle, which we will feed to these actuators. And then the actuators actually move everything. So that's the way it works. It's kind of similar to the way that Tunnel Runner demo works. If you watched my Tunnel Runner series, it's a similar concept, except this time we're using the offset and returning the mouse back to the center on every logic tick, so that we can repeat the same thing over and over again and get the appropriate values for our rotations here. So that's why we need the center. And to get the center, we need another module. So from BG, import logic and render. So X would be, half of the width of the window. So we call render get window width, and we divide that by 2. The reason these are double division signs is because we want to get an integer back. And why do we want to get an integer back? Well, I'll explain that in a bit, but for now, just know that this is what this division is doing. It's giving us back an integer. Now that's integer division. So get back to y, render.get window height divided by 2. Right? You have the width, you divide it by 2, you get this point on the x. You have the height, you divide it by 2, you get this point on the y. So you get the center of the screen. And we'll set that to a property on this class called screen center. So self.screenCenter. And that will equal a tuple of x and y, which we calculated here. Okay, so the initialization step is finished. What we have to do now is the actual offset function. So we need to get the mouse offset on every frame, and we can do that by using vectors. Yeah, vectors I think is the most convenient way to do this. There are other ways as well, you can just loop through it, but I like to use vectors wherever I can. So I'm going to get the screen center, and I'm going to convert it to a vector. So vec screen center equals vector, and then self dot screen center. And same thing for the mouse position. So equals vector self dot, and this is where the sensor comes in. So mouse dot position. This returns a list of x and y, which is converted to a vector. And now to get the offset, it's just a difference. So return vec mouse position minus vec screen center, and that's our offset. Okay, so now this class will also have a main, right? And here's the procedure. We get the offset, which is a vector, and that's just get mouse offset, but remember self, because this is the method on this current class that we're working on. Okay, so now that we have that, we can use it to actually set our actuator values. So let's see. These actuators, like self.cont, or no, self.act, rot_x, have this drot list, which you can set to basically these values here. So this list that we're setting on drot, on this actuator, corresponds to this rotation line here. So we want to rotate the camera on the x-axis by actually getting the y offset of our mouse. So as we're moving our mouse up and down, the camera is rotating on the x-axis, which for the camera is up and down. That means that we simply take vec offset dot y, right? Because those are the mouse offsets. On the y, we want that to manipulate the rotation on the x. And for the other values, it's just nothing. So rotation z, same thing, but this time we're rotating on the z and we're using the x offset. So we want our mouse movement on the x to rotate the body on the z. So vec offset dot x. Alright, and then to end this, we want to return the mouse cursor back to the center, because on the next tick we want to be able to calculate the offset again. And this will enable that. So render has this function, set mouse position, and this is why we initially created this screen center tuple instead of a floating point vector, because this way we can just split that tuple by putting this asterisk in front, typical dereference syntax in some other languages. But in Python you can use it to split this tuple into individual arguments, which is what set mouse position takes. And they have to be integers, so the fact that we did this integer division here helps. So self dot screen center. Okay, and let's see what we get. So here I am. I start and I get nothing, because of course I need to create this mouselook object. So moose. Okay. And we want to give it the controller, right? Because that's what it takes. And the controller here is logic.getCurrentController. Alrighty. And with that done, we run this main. Let's see what we get now. And it freaks out. So I'm moving my mouse now and the whole thing is just freaking out. Something's wrong. What is it? Well, let's see. When we move our mouse, the offset that we're getting back is actually integers, right? You're moving on every frame by about 3 or 4 pixels, typically, right? The faster you move, the more pixels you move. The slower the move, the less pixels you move. But you're still moving, by integer values, right? 1 pixel, 2 pixel, 3 pixel, and the rotation components for our motion actuator, they're very sensitive. They take low floating point values if you want them to produce sane rotations that don't go all over the place, which means that we have to kind of dull those values down to lower floating point values that our actuators can digest properly. That's the nice way to think of it. So I'm going to multiply this by 0.005, and that should probably do it. Okay, so let's start that again. And, alright, now this seems like it works fine, but actually it's inverted. So right now, as it's moving up, I'm moving the mouse down, and when I'm moving up, it moves down. And the same thing on the X. Moving right moves me left, moving left moves me right. Easy way to fix that is just put a negative sign in front of this 0.005, because that flips all the values in the offset vector, and that will work perfectly well. So we try that again. Okay, and now it works. I'm getting appropriate orientation. Okay. So that's successful. But, there's a bit of a problem. See, if we put our mouse cursor here and start the game, and then the first time we move the mouse, we sort of get this really, really large jump to that side. And the reason that happens is, even though if we, well, first, I forgot to do something here. You want to always set your mouse cursor to the beginning, right, to the center of the screen before you do anything else. So render dot set mouse position, and then screen center. Alright, and don't forget, split the tuple here, because set mouse position takes 2 arguments. Okay, but even that won't fix the problem that I just demonstrated, because I move the mouse and it still freaks out. The reason for that, as I was going to explain, is because this function needs one logic tick to actually update. So the mouse position sensor needs time to actually update the values that are there. And so we need to run this function only after the first tick. So the way to do that, one way to do that, is to create another variable called init, or whatever you want to call it, and you can set it to false, and say if init, then we're going to run this function. But if not, which is the else case, then we're going to set init to true. So in the beginning, mouse look will initialize, meaning that this initialization function will run, and set mouse position will set the mouse position to screen center, but main won't execute until the next run, when this value, position value for the actual mouse cursor, is updated and this main function can run properly. Right? So now, well, don't forget, you might get errors here because, init will seem like it's being declared here locally, but really it's this init that we want to use, so just declare global. Alright? And now we start and move and notice that everything's normal. We don't get that initial freak out that we had before. Right? And okay, this video is pretty long, but mouse look is not exactly trivial, at least if you're a beginner. But that's one way to do it. So hope that helped, and I'll see you in the next video.